Good morning. For this assignment, you will be demonstrating what you know about polynomial functions. This is the final assignment for polynomial functions. And so you're just going to go through and determine all the information, list all the information here, including finding all the zeros and finding the factored form. And notice that this will require polynomial long division. That's what this blank space is for. So I'll work through the first question, and then the process is the same for, there's 3 more functions here. And you're going to just do your best to find the answers there. All right? So for this one, the function is f of x equals x cubed minus 6x squared minus 14x plus 104. So for this first part, we can just check the symbolic representation and see what the answers are. For example, we know that the degree is 3. Right? We know that the degree is 3. That's the highest exponent on x. And we know that the number of zeros is always the same as that. So that's 3. The y-intercept is always the constant, is 104. And let's see, the lead term is x cubed, so it's odd and positive. So it goes from negative to positive. Goes from negative to positive, right? Negative to positive. Okay. Then we use the graph to find some additional information. So how many real zeros are there? We can see there's only 1 here at -4, and it's doesn't look to be a repeating 0 because it doesn't like flatten out or bounce off. It just goes straight through. So we say that's 1 real 0. And we think, okay, first of all, it seems to change direction over here, but it doesn't actually ever get to the x-axis. What does that mean? Well, there's 3 total zeros. If there's 1 real 0, then there's 2 complex zeros for a total of 3. Again, complex zeros always come in pairs, complex conjugates. And we're going to have to find what those are. And so you never have just 1 complex 0. There's always 2 or 4 or some even number. There can be 0, but never an odd number. Okay. So what we're going to do is use long division to find the other zeros. First of all, 1 0 is x equals -4. That means the factor is going to be x plus 4. So we're going to divide by x plus 4. So how we saw, we just go up here. We write out the function, and we're going to divide it by x plus 4. So again, we just think, what is x cubed divided by x? If it's just x in front, you just make this 1 less x, the lead term 1 less x. So if it's x cubed, you make it x squared. You multiply this x squared times the divisor, so that's x cubed plus 4x squared. You subtract it. And keep in mind, both of these will become negative signs, so these cancel out. You get negative 10x squared. Bring down the negative 14x. And again, you say, oh, what's negative 10x squared divided by x? Well, that's just 1 less x. So that's negative 10x. We multiply these together, get negative 10x squared minus 40x. Again, we change the sign because the negative, these cancel out, and this is actually negative 14x plus 40. So I think that's 26, positive 26x. You bring down the next term, the 104. Here, what's 26x divided by x? Well, that's 26. And we multiply it out, that's 26x. 4 times 26 is 104, and the same thing, so it does cancel out. All right. So here is our function. So let's set it to 0 and find our two intercepts. Squared minus 10x plus 26 equals 0. So it shouldn't be factorable because they're complex solutions. We have 2 and 13. And yeah, that doesn't add or subtract to 10. So you can use the quadratic formula here. You could put it in vertex form or use the quadratic formula. Use the quadratic formula. So negative b, that's negative 10, plus or minus the square root of b squared, then squared minus 4ac, minus 4 times 1 times c is 26, all over 2a. 2a is 2 times 1, which is just 2. So let's simplify some of this. We get 10 in front. Negative of a negative is a positive. It's plus or minus. So in the square root, we get 100 minus 104, which is negative 4. Right, so we get 10 plus or minus square root of negative 4. We know the square root of negative 4 is 2i. So 10 plus or minus 2i divided by 2. Remember, we have to distribute the 2. Division is distributive over addition. We get 5 plus or minus 2i, right? So those are our other two zeros. Plus 5 plus 2i. And x equals 5 minus 2i. Right? So these are, and remember, these are complex numbers. Even though it has two parts, it's not an expression, it's a number. So to find the factored form, we simply subtract it. So first, it's minus x minus negative 4, so that's x plus 4. There's no number in front because there's no a. Leading coefficient is 1. So we have x minus the number 5 plus 2i, and x minus the number 5 minus 2i, right? And it looks a bit more complex. Maybe that's why it's called complex numbers. But here's our factored form. It's all written out there. So again, we went through, we looked at the symbolic representation and could determine the information up here. Then from the graph, we could determine which are real or complex zeros. And we can determine those zeros using long division. Then finally write it in factored form. So the same steps are for the entire assignment. So please just go through and answer all the questions for each of the graphs. So just do your best with that. Please ask if you have any questions, attend tutoring, and just do your best on the assignment. All right, have a good rest of your day, and I will talk to you next time. Okay, bye.